Okay, so the first thing you would have to do is move that 31. And because that 31 is negative, we're going to add it. So that's your first step. Add 31 to both sides. You would have x squared plus 10x equals what? What is negative 8 plus 31? 24. Anybody else get 24? Or 23? Is it 23? Okay. So 23. And now we need to figure out what number to add to both sides. And the number that we add, because we're going to add it twice, is always going to be half of this number squared. So what is half of 10? And what's 5 times 5? So you need to add 25 to both sides. So when you factor this down, this is actually going to factor down to x plus 5 times x plus 5, which is x plus 5 squared. So x plus 5 squared equals, what is 23 plus 25? 48. So now what's our next step? Take the square root of both sides. Now 48 is not a perfect square, so we need to simplify that. So the largest perfect square that goes into 48 is actually 16. 16 times 3 is 48. And the square root of 16 is 4. So what we really have here is x plus 5 equals plus or minus 4 root 3. So when you square root the left, that just gets rid of the gets rid of the exponent. But when you square root 48, because it's not a perfect square, we have to break that down. And our last step is to subtract 5 from both sides. So x is going to equal negative 5 plus or minus 4 root 3. And that would be your final answer. Anybody make it there? Okay. Let's do one more example of completing the square, and then we'll start Appendix 7. Okay, so this is our last question in Appendix 6. So we're going to complete the square. I do that a lot. Like I'll stop recording and then I'll forget to press start again. So if you're ever not here and you watch the video, it's not going to be perfect, but it'll be, So anyway, so that's the answer. Okay, any questions about completing the square? So go ahead, draw a line in your notes, and now we're going to start Appendix 7. And the title of Appendix 7, so Appendix 6 was what we just did. That was just factoring, completing the square, quadratic formula. That was it. All refreshers, except for completing the square. That might have been new if you didn't take honors algebra 2. So now we're going to talk about imaginary numbers or complex numbers. So just a reminder, though, about homework 1. Homework 1 is due on Monday. So you have the books now. Now, make sure when you turn in your homework, I need these 3 things. I need your full first and last name. I need to know the class period. And then the homework number. So this is homework 1. These are the questions that you have to do. And you're just going to turn it in, staple it if it's more than one page, put it in that blue basket on Monday, and we're going to move on with our life. What I will also say is you always get 1 day grace, okay? So if you check Canvas, the due date is Monday, but I'll take it Monday or Tuesday for full credit. After Tuesday, it automatically drops down to 35 out of 50. Did you have a question, Josh?
Yeah, it has to be a graphing.
So this first one has no graphing in it. So we don't start graphing. I think our first, and I actually put it on Canvas. I think we start graphing when we get to chapter 1. But this is all solving. It's just quadratic formula. It's everything we did for the first couple of days. So this homework is solving equations, factoring, the quadratic formula, and completing the square. That's it. And you can see this. I just took a screenshot directly from Canvas. All right, any other questions? That's a really good question. So we have about 30 homework assignments this semester. So we're talking about 1,500 points. It's a lot of points. So not doing your homework is actually, not only are you negatively impacting your grade, but you're not preparing for the test. Because all of the homework questions, like the test comes from homework. So actually doing the homework yourself is actually going to help you if you intend to stay in this class. So that's my little homework speech. So now let's get started on Appendix 7. So Appendix 7 is called Complex Numbers, if you're titling your notes. So this material is what is on homework 2. And the appendix, since you all have your books now, so we don't start with chapter 1. We're actually starting in the back. So the appendix is in the back. So you want to go all the way to the back of the book. So the appendix is like the preview. So what we're doing is an algebra review, and then we'll start recalc. So we're in the back of the book, and then we'll go to the front. Okay. So let's get started. What is a complex number? Yes. Oh, I'll give you one at the end of class. All right. What is a complex number? It's A plus BI. Go ahead. Write this down. JJ. So you got number 223. So complex number is a real number plus an imaginary number. So for example, a complex number is like 3 plus 2i. That's just called a complex number. You can also have, even if it's just 5i, that's also complex because the invisible number in front is a 0. So, excuse me. So in this part of Appendix 7, there's 3 things you have to do, and one of those things is simplifying I. So let's talk about how to do that. So go ahead and make a list. And we're just going to simplify I. So I just want you to make a list. This is an actual pattern. So I would make it, so we're going to start here. I squared, I to the third, I to the fourth. And we're going to go all the way up to I to the 12th. And it is a pattern. Okay, so I is just equal to I. I squared equals -1. And then after that, you can kind of reason through it a little bit. I to the third is the same as saying I times I squared. Okay, so if it's I times I squared, that means that it's going to equal I times -1. So I to the third is just -I. I to the fourth is the same as I squared times I squared. And I squared times I squared is +1, because that's -1 times -1, or just 1. When you simplify I, these are your only 4 answers that it could be. So I to any power is going to equal one of these numbers. Okay, so once you hit I to the fourth, or a power of 4, we know that it's always going to equal 1. So I to an exponent that is a multiple of 4 is always going to equal 1. So I to the fifth can be written as I to the fourth, because I know that I to the fourth is 1 times I. So what is I to the fourth? I to the fourth is just 1, and it's just be I. So 1I, or just I. I to the sixth is the same as I to the fourth times I squared. I to the fourth again is 1, and what is I squared? -1. I to the seventh is I to the fourth. Every time I try to write at this part of my iPad, it doesn't want to write, and that's really strange. I don't know why. All right, but that's 4 times 3. So again, I to the fourth, anytime you hit a power of 4, we know that that's just 1. So I to the seventh is the same as I to the third, which is just going to be -I. And the last one, I to the fourth, I to the eighth is I to the fourth twice, which is just going to be 1. So it's a cycle. It goes I, -1, -1, 1. I, -1, -I, 1. So again, these last 4 are going to be the same. I to the ninth is the same as I to the eighth times I. I to the eighth is 1. We already know that because we see this here. I to the eighth is 1. So what do you think my first answer is going to be? What is I to the ninth? Just I. I to the 10th is I to the eighth times I squared, which is -1. I to the 11th is I to the eighth times I cubed, which is -I. And I to the 12th is I to the fourth 3 times, which is 1. So what I want you to do, if you know this, if you know these right here, this is what I want you to put a box around or highlight or whatever. Because if you know these first 4, then you know them all. So we're going to simplify powers of I. Okay, so let's go ahead and copy down these 4 examples, and let's see if you can figure out what they equal. So I to the power of 29, I to the power of 67, I to the power of 42. Is that a 42? Yeah, 42. and I to the power of 24. So take a minute, copy that down. Get my coffee so I can wake up because I'm not awake. Okay, so I to the power of 29. So if you're counting by fours, how high can I count by 4? What's the highest multiple of 4 without going over 29? So we got to know our timetables, our fours. 7, right? Because 4 times 7 is 28. So what I'm going to do is break this apart to I to the power of 28, because I know anytime I hit that 4th, it's just 1. So I'm going to break this apart to I to the 28th times I to the 1st. Because I to the 28th is going to cancel out. That's just going to leave me with 1. That's just 1. So I'm just left with I. So my answer is I. Remember, it's either going to be I, 1, -1, or negative I. All right, so now we got to think about 67. And this is, it's early in the morning, so I don't know if I know this one myself. But how many times can, what's the highest multiple of 4 and 67? 60? 16. So that means I to the power of 64. So 64 divided by 4. If you divide 64 by 4. Okay, so we have I to the power of 64. And let me explain why I did that. Because 64, that's a multiple of 4, so that's going to equal 1. And then how many i's do I have left over? 3. So you just have to remember, what is I to the power of 3? I to the power of 3 is what? Negative I. So this cancels out. That's just 1. And if you look at that chart that I had you write down, just those first 4, I to the power of 3 is the same as I squared times I, which is negative I. So my final answer would be negative I. And this is I. All right, go ahead and do the number 3. So I to the power of 40, that's as high as you can go. So you're really left with just I squared. So what is I squared? Negative 1. So that would be your final answer. And then 24 is a multiple of 4. So what is that going to be? Just 1. So that's the first piece of Appendix 7. The second piece is doing some operations. So let's go ahead and copy down these examples. Go ahead, copy down these 4. We probably won't get through all of them, but we'll see how far we can get. Now these two won't take a lot of space because you're just combining like terms, but for these we have to make boxes, so you might need a little bit of space. So okay, so for number one, you're just combining like terms because it's addition. So you're adding your real numbers and you add your imaginary. So addition is quite simple. So all you're doing is adding together the 2 and the 7. And what is 2 plus 7? 9. And then you're adding your imaginary. Negative 5i and 3i. So it's kind of like negative 5x and 3x. They're like terms. So you're adding the numbers in front, which will be a negative 2i. And that would be your final answer. Just combining like terms. For subtraction, though, you have to distribute that negative. So it becomes, I'm going to rewrite that as addition. So that 8 is a negative 8, and the negative 4i is really a positive 4i. So I always rewrite subtraction as addition. You just distribute the negative and you combine your like terms, just like you did in number one. So when you add your real numbers, you get 3 and negative 8, which is a negative 5. And 11i and 4i is 15i. And that's it. All right, let's look at number 3. For number 3, because it's multiplication, and you're probably used to making a box, we're going to just make a box. So let's make our box. And now we're multiplying. So 3 times negative 2 would be a negative 6. Negative 2 times 4i is negative 8i. 3 times negative 5i is negative 15i. Now this box here, though, we're going to have an exponent because you have negative 5i times 4i. So I'm going to actually do some work on the outside. When you multiply to get this last term, you get negative 20i squared. But you cannot leave an exponent on I. The only exponent you can leave on I is 1. And what does I squared equal? What did we just say that it was if you go back? So this is really, right here, you really have negative 20 times negative 1. So in this square, you have a positive 20. So when you combine your like terms, start with your real numbers first. So I'm going to start off with these two. Negative 6 and 20. When you add that together, you get positive 14. And then we're going to add together the imaginary. And that would be negative 15i and negative 8i. And what does that give you? Negative 15 plus negative 8. Negative 23i. And that is it. All right, go ahead and make a box for number 4. That's our last question. It's multiplication. When you don't see something in between, that means we're multiplying. See how we had a subtraction sign, we had an addition sign, but now there's nothing there, so that means we're multiplying. So go ahead and make your box. See if you can get to the end by yourself, and I'll put up the answer in a couple of minutes. All right, so in the first square, we have a negative 12. In the second square, we have an 8i. Third square, bottom row, first square, bottom row, negative 3i. And then in this one, we would have 2i squared. But 2i squared means 2 times negative 1. So we have a negative 2. Combine your like terms, and your final answer should be negative 14 plus 5i. Who had that? Negative 14. Negative 14 plus 5i. Okay. Well, we're going to finish Appendix 7 on Monday. We didn't quite get a chance to do that. Please don't leave your books behind. Take it home. Leave it at home. Homework 1 is due Monday. Have a good weekend.